In this nugget, you and I get to take a look at the concept of a hypervisor, including two different types of hypervisors and how they operate to create virtual environments for other guest operating systems to go ahead and run. Let's begin. I'd like you to imagine that it's 20 or 30 years in the future and you and I are going to a movie. However, movies of the future are not like the movies of today where we sit in a chair and we watch a film. In the future, we get a full body suit and they hook us up into this apparatus. And as part of the movie, they feed all five of our senses: our touch, our sight, our taste, our smell, and our hearing. And here's my question. If we were in these suits and having all of our senses fed, is it possible that we might not realize that we're in a movie and we might think that's part of real life? Well, if the technology is good enough, it's very likely that we would believe that we were actually part of real life and not participating in a movie that we went to watch. Now, we can apply that analogy of the movie theater of the future faking us out by providing content to all of our senses. We can apply that to the world of virtual machines and virtual environments today. For example, if we take a physical computer like a Windows computer and we power it up, it's going to do several things. There's going to be electricity that's sent to the motherboard. It's going to take a look at the read-only memory and the BIOS, the basic input-output system for that device. It's going to do a power-on self-test. It's going to read information from the complementary metal oxide semiconductors, which is just a chip that's remembering things even when the computer is powered off. It's going to boot to the hard drive. There's going to be a hardware configuration that's somewhere looked at to identify all of the hardware and associated peripherals that are attached to this machine. It's going to load drivers, and that includes device drivers and system drivers. And eventually, when it's done, it'll create a user interface for a human to interact with it, whether it's a command line interface or a graphical user interface. Now, as part of this Windows machine booting up, it made a list as it booted up of the things that were attached to it. For example, is there a keyboard? Is there a mouse? Is there a monitor? Information about the drives, whether they be hard drives or optical drives or floppy drives. USB port information. The memory that's available to the system. The PC knows about all of those. And then with the appropriate drivers, it's taking advantage of those resources. Now, when we compare that to a virtual machine, when a virtual machine boots up, for example, it also could be Windows. However, we don't really have the keyboard, mouse, monitor, drive, USB, and memory that are dedicated to that device. Instead, in a virtual environment, we can create a list of the elements that we want to make that operating system believe is available to it. For example, the keyboard, the mouse, the drives involved, USB ports, the memory, and adding onto that the type of CPU that's involved, how many sockets and how many cores. And so as a virtual machine boots up, it believes it has this nice laundry list of features that it can use. But instead of having the physical resources like the real PC does, all of these resources here are virtualized. Or if you want to think about it another way, we can say those are lied about. And that, my friend, brings up the next logical question. What type of a system or software would have the ability to go ahead and lie about all of these resources to an operating system so it believed that they were actually right there? And the answer to that question is called a hypervisor. A hypervisor is some type of a system, normally in software, that emulates these resources so that other operating systems like Windows or Linux can actually boot up and believe that they have those physical resources available to them. I mean, from the operating system's perspective, it looks and feels like a keyboard. It looks and feels like this type of processor. The hypervisor has created this virtual environment for that operating system. And so just like us at the movies in the future, the current operating system does not know that it's in this virtual environment. It's simply running with its input and output and using the resources it thinks it has. And when we have a system like that that's running this virtual environment, we call it a virtual machine. So the purpose and function of a hypervisor is to create an environment for an operating system to run where that operating system believes it's the real deal, doesn't know the difference. Now, regarding the types of hypervisors, there's basically two. We have a type 1 and a type 2. And again, whenever we think hypervisor, think of the entity or software that's creating that virtual environment for some other operating system to run in. And let's start with a type 1. Now, we have to have some hardware somewhere that's actually providing the functionality. So we're going to call this box host number 1, the physical box that's going to be running our hypervisor. And a type 1 hypervisor, also called a bare metal hypervisor. On our hardware, we'd have the hypervisor running directly on that hardware. And then on top of that, we could have our virtual machines. For example, maybe we have a Windows virtual machine running as a VM. Maybe we have a Linux running as a VM. And the fun part is that the Windows machine believes that it's running on a real dedicated PC. It doesn't know the difference. This Windows machine has been lied to and led to believe that it's running on its own little dedicated set of hardware, when in reality, the virtual environment that Windows is running on this host, that VM is all virtualized. So this is an example of a type 1 hypervisor, where we have physical hardware, the hypervisor runs directly on that hardware, and creates the virtual environments for these guests. So for example, the Windows machine would be a guest virtual machine. The Linux operating system running in its VM would also be considered an example of a guest virtual machine. Where the bare metal hypervisor, in a type 1 scenario, with the physical equipment that hypervisor is running on, are acting as the host. A type 2 hypervisor does not run directly on the hardware, and we have some type of a host operating system. For example, that host operating system could be Windows, or Linux, or Macintosh. So whatever our host operating system, Windows, Macintosh, or Linux, that's running and installed on that computer just as if it was a normal computer. But then on top of that, we'd run a separate application, and that separate application would be our hypervisor. Specifically, our type 2 hypervisor that's running on a computer that's currently being managed by a host operating system, like Windows, Linux, or Mac. So then within this hypervisor, we can create our virtual machines for Windows, and our virtual machine for Linux, or a virtual machine for iOS, which could include the iOS from Apple, or it could include the iOS from Cisco, depending on what type of environment that we're emulating. And because this hypervisor is simply just an application that's running, this same computer, which we'll call host 2, could also run other native Windows or Linux or Mac OS applications. For example, if they wanted to run a word processor or a browser or some other application, because the hypervisor isn't consuming the whole box, from a functionality perspective, we have the best of both worlds. Now, regarding an example of a type 1 hypervisor that runs directly on the hardware, a great example of that would be VMware's ESXi. And an example of a type 2 hypervisor where we have a host operating system in place like Windows or Linux or Mac OS, and then we run the hypervisor as an application. Examples of that would include VMware Workstation. Other examples of type 2 hypervisors would include Oracle's VirtualBox, and GNS3 for emulating network environments would also fall into that category, because there's a host operating system, the hypervisor is running as a specialized application, and then within that application we can virtualize devices. One of the cool things about a type 1 hypervisor is that we don't have overhead from a host operating system like Windows or Linux or Mac OS that are going to consume quite a bit of resources as far as hard disk, memory, and CPU. If we have a type 1 hypervisor, the only memory and CPU and resources that are taken up by default from the starting gate before we create any new virtual machines is the hypervisor itself. The footprint is just going to be a small fraction of what Windows, Linux, or Mac OS would be taking before we even start the hypervisor running as an application. And in the case of Mac OS, VMware's hypervisor that runs on top of Mac OS is called VMware Fusion, which is another example of a Type 2 hypervisor. In this nugget, we've taken a look at the concept of a hypervisor, creating a virtualized environment for another operating system to go ahead and run. One of the tools that I've embedded for you and I to use at the very end of many of these nuggets is a quick assessment, just to make sure that we got the concepts that were taught in this nugget. So as a result of your and my time together in this nugget, we should be able to answer the following questions. What function is provided by a hypervisor? Which hypervisor uses less overhead, a type 1 or type 2, and why? And third, what are examples of type 1 and type 2 hypervisors that are created and produced by VMware? And so if you're having a challenge with any one of these questions, I would encourage you to maybe review that part of the nugget again and then come back to the assessment here at the end. I appreciate you joining me for this nugget. I hope this has been informative for you, and I'd like to thank you for viewing.